So in our forces unit, the first thing that we're going to look at is we're going to look at just some common forces and understand how we would draw them appropriately so we can best work through problems. So forces is just defined as any push or pull on an object. There can be field forces, such as gravity or electrostatics, where you don't physically have to contact something, or it could be a contact force where you're actually pushing on something. Forces are going to be measured in newtons. We symbolize that with a capital N, and we'll learn that as we start to work through the math of what 1 newton actually means. But I wanted to just go through some common forces and how we would draw them. So the most common force, almost everything we're going to deal with has it, is gravity. So if this is the Earth, and we're talking about an object that is falling through the air, maybe it's moving downwards. It's moving downwards because there's a force pulling on it, and that is the force of gravity. So what I'm going to do is I'm going to draw from the middle of that object an arrow pointing straight down in the direction, and I'm going to label it FG. That's how we would indicate the force of gravity. Another force that we're going to look at is something called the normal force. A normal force is if we have, a book or something sitting on a table, there's going to be 2 forces acting on this book. One of them is going to be the force of gravity pulling down. The other one is going to be the normal force. Normal force is going to act perpendicular to a surface. So the surface that this book is sitting on is the table. And so the normal force is the book pushing up, the table pushing up on the book. You could also think that there is a normal force on the table itself. Fn is pushing on the table. That's the book pushing on the table. So this normal force is the table pushing on the book because they're in contact. This normal force is the book pushing on the table because they're in contact. But a big thing with normal force is it is always perpendicular to the surface of what it's touching. Another force would be tension. So if we have an object that is hanging from a string, it's also going to have 2 forces that are acting on it. This one's going to have the force of gravity down. And the second force would be our tension force, which we could call Ft, or just sometimes you'll see it represented as just capital T, indicating that that's the tension force. Our last force would be of any kind of push or pull. Right? So if we have a box and we're pushing that box, it's magically levitating above the floor, but if we were pushing that box or pulling that box, right, we could be maybe pushing down at some angle. We would also have a gravitational force, and we'd have a normal force. Okay? So those are 3 common forces that we're going to deal with. And as I'm actually talking about this, I noticed one more force that I didn't really think about, but the last one would be friction. A friction force is any force that's going to oppose the motion through the roughness or the air resistance. So if we're pushing this object to the right, there's also going to be a frictional force opposing that motion. And so we draw that force of friction like that. Now there's 2 ways some people draw friction. Sometimes they'll draw it down at the end because it's pushing on the bottom of the surface. You can also draw it from the center of the object, just like all the other forces. And I'll point this out that when we draw forces, we want to draw, these are free body diagrams or forced body diagrams, right? And you'll notice that we always draw the forces that are acting on the object as if they are as if they're starting from the center of the object. So what I don't do is I don't draw gravity like this, or I don't draw normal force like that, right? It's typical that we're going to have it set up where the forces, the arrows, always start from the center of the object, and then they're pointing in the direction that they are being acted. So tension is pulling up, gravity is pushing down, instead of drawing the forces opposite like that. So having the forces drawn like that is going to help us as we start to work through problems, as we start to figure out what the net force is, and to understand how objects' motions are going to change. When we talk about rotation, it might change a little bit, and that's why some people will draw friction down like that. But it's a pretty common process to start the force diagram with the force starting from the middle of the object.